Hello everyone. So I am back. Greetings for the day. So today I will be making our second playlist, and this agenda of today's lecture will be also a topic which has been added newly in the syllabus. So this is the syllabus, and this particular topic of additive manufacturing which has been added that we will be discussing today and in the subsequent lectures. So first, to understand this, let us start it. Now the problem is not the problem. Let's start with agenda. So our agenda is additive manufacturing. Now to very well understand this topic and the depth to which we have to go to it, we have to first understand where is this topic lying in. So they have added this topic under the head of production, like with all other topics of production where these casting, forming, joining, etc. This additive manufacturing is added. And as you know that in GATE they never have shown any mercy while asking the questions from this area. And the questions were, I would not say very difficult, but it was not very shallow also. The concept what they expect from you people is decent. So uh, I guess we have to study this topic also a little bit with extra care, because there are many small things which are there and you have to know it. Also, this is a very advanced topic, advanced as in evolving topic, and the future is in additive manufacturing. So there are many things which are being evolved day by day. So to have an understanding of it is important. Fine. So let's start with the introduction part. I guess every one of you know what is manufacturing. I will just brief it because this is for the sake of it. And in the very first lecture, I generally discuss the layout of the entire subject. When I say layout, it means how I will be taking up this particular topic, how I will be dividing it into sub lectures. And then, if you remember this first lecture, first layout, I'm pretty sure you will understand the basic skeleton of the subject, and then you can always read any particular topic in detail to develop your understanding. So let's start with the introduction part. The first portion is manufacturing. Now, I guess you must be knowing what is manufacturing. It is to make any product which is meeting our desired service or need. Fine. So now this service or need are basically of three types. First one, of some desired service or need. So desire can be in terms of shape or size, or it can be in terms of some properties related to mechanical property like strength or the ductility or the brittleness, or it can be in terms of surface finish. These are the in general very basic type of properties what are desired by the users in day-to-day thing. So now in when you come to the shape and size, it is in general made by many other processes which you already know, like casting, welding, or milling. So there are many. When you talk about properties, then you can alter the properties of any given metal by some heat processes, heat treatment, or by some coatings. Similarly, if you talk about surface finish, then there are three very primary surface finish methods. What you know, one is lapping, honing, buffing, etc. So this is what is called manufacturing, and you have almost read about all these things. You know how to manufacture something already. So why this new topic was added? So to know this, you have to basically understand something which is known as this manufacturing can be done in two good ways. When I say two good ways, I mean the approach. So this approach can be either to have a technological way or an economical way. Now, they are not very independent of each other, they are very much dependent, and how they are dependent, I will talk about this after some time. Means they are both are related. For now, you should know. Means, a, if even if you develop some technology which is not very economical, it will be of no use. And something which is very technologically advanced but not economical, it is not going to work. That is pretty much, you can understand this. Okay, so in terms of manufacturing, this particular two topics I will come when we will be comparing our conventional and additive manufacturing things. Right now, you have to hold it for a while. Now, then comes when you talk about manufacturing, then there is something called as subtractive manufacturing. Subtractive manufacturing, and then another one is called additive manufacturing. Now there are many ways, many names for this additive manufacturing. One is additive manufacturing. Some people also call this as rapid prototyping. But I must say, prototyping. I must say this is also said by RP. This is shown by AM. But there is a slight difference between additive manufacturing and rapid prototyping. RP is the subset of AM. I mean that if additive manufacturing is this big thing, then RP is just a part of this. Means they both are not very much like RP is a subset of additive manufacturing. This additive manufacturing is also called as freedom fabrication. Freedom fabrication. Why it is called so? You will understand. We will when we will talk about different uh, topics. Then 3DP. This is 3D printing. 3D printing. Then it is also called as your stereolithography. Lithography. Actually, this is a method, but this method was the first particular method by which we started, and then it became a very common term for common representative name for additive manufacturing. Actually, this is a method. Like if I say milling, then milling is a metal cutting process. Fine. You cannot say that metal cutting process and milling are one to one same. But still, milling is so common, like in turning is so common that if someone is telling you turning, you understand that okay, fine, it is some sort of subtractive manufacturing. Okay, now this thing, subtractive manufacturing, is also called as top-down approach. Top-down approach, and this particular is called as bottom-up approach. And I would again try to remind you that till now I haven't started the topic. It is just I'm laying out how additive manufacturing is related to something what you already know. So now let us come back to the basic difference between these two things. And it will be best shown by a drawing. Now the first thing what is here shown here, this is the your subtractive manufacturing, this thing, and this is your additive manufacturing. What is the primary difference between these two? You should know. Now, in subtractive manufacturing, we start with a bulk of a material. Then we do some machining processes and we subtract some material from this. Now, you can pretty well see that initially this was, suppose this was a cube, and this cube dimension was a cross a cross a. Then you removed some material, you did some milling operation suppose, and you removed some material and you made a component. This is your desired component and this is your waste. Okay. In additive manufacturing, what we do, we start with some materials which are in not the form exactly similar to your final form component. It is in terms of either it can be powder, it can be liquid, it can be polymer, what all can be the states and type that I will discuss. But right now you should understand that this starting material are not similar. In this you see your starting material and the final component, they are very much similar. In this it is not necessary. Then we feed this material into your additive manufacturing machine, which do some sort of mechanism, like processes is done by layer things are added one on top of another, and then a final 3D object is formed. Then some waste is also there. Let us call this as waste as W1 and let this waste be W2. Now, the primary difference, what is there in between these two methods, is very nice. See, suppose if you want to make a object of this shape, and this shape should is of B, then you should always take care that the dimension of this B should be either less than or at max equal to this A. This B should at max be equal to A. Suppose if you want to make, if your starting material is cube and you want to make a ball, then the maximum ball by which can be smaller than this cube only. If this dia is B and this is A, then B can at max be equal to A. This is pretty much what you can understand. But in additive manufacturing, no such limitation is there. Okay, like even if this is B and this can be either liquid or it can be your solid or it can be your powder, means there can be different things. It can be of any shape and size in the starting material, and your final object, no such dimension restriction is there. Then second thing, this waste, this W1 and W2, this W1 is always greater than this W2. It is always so. In subtractive manufacturing, whatever waste you are getting, that waste is always more than whatever the waste you are getting in corresponding additive manufacturing. And you also know that these waste has to be recycled. This waste has to be recycled. Suppose if this waste is not recycled, then it is not sustainable. Sustainable manufacturing. If this is not, then this is non-sustainable manufacturing. So this waste has to be recycled. If this waste is not being recycled, then this entire manufacturing cycle will not be sustainable. So to have a sustainable subtractive manufacturing, this waste has to be recycled. And then there is an input of energy or money in recycling. So this input of money in recycling the waste is very high in terms in your subtractive manufacturing, whereas in additive manufacturing this recycling is not very difficult. First of all, the second, this waste is so less that these recycling, even if you skip for a while, that will not create any trouble. So these are some primary difference between these two. Now I will talk about the layout in which term we will be studying this entire subject. Again, I would like to pull out the drawing where I was discussing about our thing. Yes. So this is the thing. So these are our material. This is our additive manufacturing layout. So how we will be studying it? So our first chapter today, what we are studying is the introduction. I will write here intro where I have just talked about some primary things, then we will further talk about it. Our second lecture will be based on the steps in AM processes. Steps in AM processes. Once we know what are the steps you take to do any AM additive manufacturing processes, then we will compare our additive and subtractive. Now, here a word of caution is that when we compare, that doesn't mean that we are trying to find out which is better. We cannot replace one with another entirely. It is just that we will be talking about advantages of both the methods, and when and if necessary, we will be choosing that particular method. Because in some cases, additive manufacturing is very powerful, and in another cases, your conventional manufacturing will be very powerful. I will just give you an example, very simple. Suppose if you have a square block and you want to make a circular hole in center, then this is best done by subtractive manufacturing. Whereas suppose you have a cube, and in this particular cube you want to make a hole of this sort, then in this case the best way is to do go by additive manufacturing, because it will form by layer, and then these profile or hole or micro channel, anything of this sort can be very easily fabricated. So then we will compare both of them in detail. Then our fourth one will be different type of AM processes. Now, when I say different types of AM processes. Now, these all types depend upon your input material and the way the manufacturing is being done. So, what all can be the different type of AM processes, that we will discuss about this. In this, there will be a big list, and this will be a pretty long chapter. This I am not sure I can finish in one lecture, but there will be uh, like 2 3 lectures it might take, and it is very important also, because in this only we will talk about different types of defects which can come, types of defect, then mechanism, etc. And then at last, your fifth lecture, what or the fifth topic, we will be discussing about, we will take some questions, because how the questions can come, that I will give you an idea of this. Fine. So this will be our layout. Our first one is intro. Second one will be the steps in AM processes. Third one, we will try to compare when and how negative and positive, like additive manufacturing, when in which case you should use which one. Then different type of AM processes, and then at last you will take some questions. Now, what all are the different types of AM processes what we will be studying? I will just brief it down so you will have an idea. So, just now what we discussed was this thing. In this, see what I was telling, that these materials, input materials. In additive manufacturing, we have a very wide range of materials, and these materials, how we start from is very important. It can either be gas, it can be liquid, or it can be solid. Now you should know that as the thickness requirements are substantial, it's not very less. So generally we try to eliminate gas as the starting material. It's not that gas cannot be used, but we don't use gas because the layer thickness, you need to add layer over layer. So in gas, if you use this, then the layer thickness will be very less, and that's the reason why we eliminate gas from the option. Okay. The second one is liquid. Now this liquid can be of many things. It can either be of your polymer, it can be either be your yeah, it can be generally polymer what we use as liquid. Then in solid, there can be your powder, it can be your wire, or it can be your sheets. Easy way to remember is that this powder are 0D, this wire are 1D, and sheets are 2D. Okay. Then this powder can be of, it can be of either metals, or it can be of polymer, or it can be of ceramic, many things. This wire can be of your polymer, it can be of your metals. Generally for ceramic we don't have this. For sheets we can have our paper or polymer laminates, etc. Now, which way you are using means when you use as your powder polymer, like polymer in powder form with a laser, then that method is called your SLM, sorry, stereolithography. So similarly, there are many steps to it, like some of the methods. I'll just give you an example. When you use food polymers in liquid state and you try to solidify them with laser, then it is called your photopolymerization. This is one. Suppose you use polymer in powder form plus laser, then this is called stereolithography. It is also called SLS, stereolithography. Sometimes it is also called STL. Suppose if you are using your powder of metal, powder plus metal plus laser, it is called SLS or SLM. This is your solid laser sintering, solid laser sintering. SLM is your solid laser melting. Then suppose we use our, this was we were using as powder or something, okay. Suppose if in case you use filaments, or these are also called as wires, okay. Suppose this filament is of your polymer, then the basic method is your extrusion, or these are also called as inkjet printing. Suppose these are of your metal, then this is also the mechanism of extrusion, but this is after forming droplets. If suppose sheets are left, suppose you use some sheets, and these sheets either can be of your paper or polymer, or these can be of your some laminates, etc. So these one is called as LOM method is there. This LOM is laser laminates something something, okay. So these some methods are there. These all we will be reading in our lecture 4. That's why I told you that it is not a small thing. It will be a very that lecture 4 will take some time to us. So similar, all these things one by one we will study. Like what is this sintering process, how it is different from melting, how this laser can like change the entire dynamics of things. So that is our plan. So that's the reason why this first of our lecture was more of introduction. In this, I have just given you the layout of our entire topics, how we will be studying. So it will be in general this. Okay. So first will be our intro. Second, intro means already our intro you have understood the layout where we have discussed. Then steps in the things, steps in AM process in particular. Then I will compare both the positive and negative aspects of our AM with subtractive. Then some different type of AM processes where I have just talked about these many methods. Okay. And then at last some questions, and with those questions we will try to understand more of the working of our this additive manufacturing processes. So with this, I will be closing today's lecture. Thank you for being here. Kindly like, share and subscribe. If you feel so it is helping you, share it with people to whom it may help. Thank you. Jai Hind.